Join today to take your SAT prep to the next level. Members get access to over 1,000 solution videos answering the questions in College Board's question bank and concept-based practice questions with videos to solidify your SAT skills. Thanks for watching. Grateful. Okay, let's start with question number 1. This question here is an example of what we refer to as corralling. And corralling is the idea that sometimes it may not be better to directly solve for x. In this situation, if you look at the difference between what we're given and what we're being asked for, it's just a matter of taking it from 4x plus 6 to simply 4x. So if you have 4x plus 6, to get to 4x, just take away the 6, and now you have 4x is 12, and that matches answer choice C. Going over to question number 2, here we have a couple of parallel lines, and what the question's really asking us about is the idea of corresponding angles. So if I have parallel lines with a transversal, any two angles that occupy the same position, those are called corresponding angles, and by definition, they're going to be congruent. Their measures are going to be equal. So coming over here, we do have corresponding angles because we're looking at the bottom left quadrant of each of those intersections. So the 170 and the W, they're equal to each other, and that means that our answer is D here. Now going to question number 3, here we have 10 values, and we're being asked for the mean, which is the actual average. The average is the sum of the numbers over the number of numbers. Now, if you add all 10 of these numbers up on a calculator, you'll get 90. And there are 10 of them, so we'll divide by 10. And 90 over 10 is 9, and that's our answer. Going over to question number 4, if the word problem scenario is a little confusing to you, what we recommend is for you to describe your variables. That'll give you a little clarity. It's one of many ways we think you should think on paper as many times as possible. So for us, that means looking at what B is, it's the number of birds, and what R is, the number of reptiles. So B is the number of birds, R is the number of reptiles. And so if the business cares for 16 reptiles, that's allowing us to be that much more certain that R is 16 because it's the number of reptiles. So we're plugging in 16 for R. Let's go ahead and go through that. 2.5b plus 5 times 16 is 80. Surprisingly, 5 times 16 is 80. So this is one of these scenarios where you just feel like you're doing something wrong because you end up with 0. And why should you get 0 on a word problem? But it's okay. It is equal to 0 here. You divide by 2.5 and you'll get 0. So how many birds can it care for on this day? Well, we got 0, so the answer is A. Going over to question number 5 now, here we have a cube. A cube is a type of rectangular prism, and on the formula sheet, the volume of a rectangular prism is length times width times height. The difference with a cube is that length, width, and height are all the same number. So it would be 41 times 41 times 41, which is 41 cubed. Putting that into the calculator, you get 68,921, which is answer choice D. Going over to question number 6 now, there are so many ways to do a simple percent, but what I'd like to emphasize right now is the idea that the word percent means for 100 in the original Latin root. So let's look at this. We can say 13 is P%. In other words, P over 100 times 25. And we can solve it that way. Now, of course, a percent is also a part over a whole. So we can say, well, 13 must be the part and 25 must be the whole. And either way, you'll get the same answer. So doing it the first way, 13 equals P over 100 times 25, which is really itself over 1. 25 over 100 simplifies to 1 over 4. So p over 4. Now we can multiply by 4 and we'll get p equals 52, and that's our answer. Going to question number 7 now. Here we have a situation and we're being asked to fit it into an exponential equation. How do we know these are exponentials? Because the basic format of an exponential is that it starts at some amount, it changes by some amount through multiplication a certain number of times. And we have some advanced applications of this equation that you should also know for a harder problem. But coming over here, if we just follow the basic format, a times b to the x, it's starting at 15,000. It's going up by 4%. Now, how do we do that? To go up by a certain percent, you start at 100, and then you increase or decrease from there. That'll take you up to a certain number. For instance, up 25 takes you to 125, or down 25 takes you to 75. And then when you put them both in decimal form, you'll have 1.25 or 0.75. So multiplying something by 0.75 means you're lowering it 25%. Multiplying by 1.25 means you're raising it 25%. Here, we're raising it 4%. So if we started at 100, we could go up 4 or down 4 from there, up to 104% or 96%, and in decimal form, 1.04 or 0.96. So here, it's increasing by 4%, so that's 1.04. And that's going to happen x times. So which equation models this the best? It looks a lot like answer choice D here. Join today to take your SAT prep to the next level. Members get access to over 1,000 solution videos answering the questions in College Board's question bank, and concept-based practice questions with videos to solidify your SAT skills. Thanks for watching. Grateful. Going over to question number 8, here we have a quadratic situation. How do we know it's a quadratic? Because it's a variation of y equals x squared. Once you realize it's a quadratic, that's your reminder to get everything on one side equal to 0, preferably with the x squared term being positive. For us, that's going to mean adding 4x squared to both sides and adding 7x. So if we do that, we'll have 4x squared plus 7x minus 36 equals 0. Now, from this point, the first choice is factoring. But if the numbers are a little big or annoying, or if it simply doesn't factor, the next thing you should turn to is the quadratic formula. Now, if you don't have this memorized, you definitely should memorize it, because not only do you need it, of course, for the SAT, but there are other things you have to do that depend on knowing that formula, in particular, the discriminant. Coming back over, let's write out the equation, negative b plus and minus the square root of b squared minus 4ac all over 2a. In our situation, a is the number 4, b is the 7, and c is the negative 36. So negative b is negative 7 plus or minus b squared, 7 squared, which is 49, minus 4 times a, 4, times c, negative 36, all over 2a, which is 2 times 4. So multiplying out the negative 4 times negative 36, that's positive 576. Now, most of the mistakes that you'll see on the quadratic formula come from forgetting that we should just get one single number here and one single sign. So 2 negatives makes it a positive, and you'll be a lot more organized if you just have this part and then the other part with whatever the correct sign is for that green part. So that's 49 plus 576 all over 8. Now adding under the radical, and we'll get 625 all over 8. And now the square root of 625 is 25, so negative 7 plus and minus 25 over 8, And now we can split it into the two options. -7 plus 25, well, that's 18 all over 8. -7 minus 25, that's -32 over 8. So this simplifies to -4. This simplifies to 9 over 4. And so we have one positive answer and one negative. They're asking us for the positive. And so that's B, 9 over 4. Going over to question number 9 now. Here we have two sets of data where the layouts of the sets of data look identical. And the answer choices are asking us questions about standard deviation. So let's go off to the side and discuss what standard deviation is. Let's imagine we have two sets of data that both have the same range. So the outer values are the same. They also have the same average, the same center. But on one of them, the other values are generally more spread out. And on the other, the rest of the values are generally more inwardly oriented. So the top would be the idea of having more deviation, or they call it standard deviation here. Or here, we're having less deviation. The values are not deviating as much. Instead, they're more centered. So here, we have two sort of parallel sets of data. Here are the numbers 1 through 7. Here are the numbers 14 through 20. So the numbers are each shifted over by about 13, by exactly 13. So 1 to 14, 7 to 20. But the way the numbers fan out, wherever they're located, is absolutely identical. That's the idea of having the same standard deviation. And the answer that says that these two sets have the same standard deviation is set B here. Going to question 10 now. This question is really asking people if they know whether f of x is the same as y, and it is. So when the question asks you for how many values of x is y equal to 0, we're supposed to look along the y-axis, and where is it equal to 0? Anywhere along this line. So the function is hitting y equals 0, 1, 2, 3 times at -1, 0, 4, 0, and 7, 0. So the answer here is C. Now this question, kind of like question 10, is asking us about our understanding of f of x, or in this case, g of x statements. In other words, how many people know that this statement means that x is 3 when y is 2,375? Seeing it that way, you can just take the function they gave you and plug in the x and the y where they go, because f of x, g of x, h of x, those are all fancy ways to say y. So we can put the y value right there. That equals 19 times a to the x value right there. So now we have an equation we can solve. The first thing to do here would be to divide both sides by 19. And 2,375 divided by 19 is 125. So 125 equals a cubed. Right now our variable is to the third power, so the opposite is to take the third root, the cube root of it. And so a is right now equal to the cube root of 125, which is 5. So now that we know that a is 5, we can rewrite the equation. We can say g of x is 19 times 5 to the x. Now, by the way, a is being called a constant. What is that? A constant is different from x and y. X and y are numbers that are constantly changing. But if something's called a constant, it's not changing like an x or y. It just is what it is. Once you find that value, it is that value forever. So if we had 19 times a to the x, from now on, this is 19 times 5 to the x. And so what's g of 4? That basically means that we're just plugging in x equals 4 here. So 19 times 5 to the 4th. And on the calculator, 5 to the 4th is 625. So that's 19 times 625. And once again on the calculator, That comes out to 11,875. Now going over to question 12. Here, we're hearing that this is a system of equations. We don't really need to be told it's a system. When you have more than one equation and we're being asked about the answer in any way, that's a system of equations. In other words, we're looking for the intersection of these two functions. And for an intersection, you want to get both equations in the y equals format and set them equal. So that would look something like this. X minus 2, x plus 4 equals 6x minus 12. Then we can start solving. We can FOIL out. We can do first times first, which is x squared, outer times outer, which is 4x, inner times inner, which is negative 2x, and last times last, which is negative 8. Now we can combine some like terms. Now we want to tell ourselves this is a quadratic. That means you should get everything on one side equal to 0, preferably with the x squared side being positive. So if we take away 6x and add 12 to both sides, we have this. Now we're in a nice BC factoring situation where we have a BC quadratic because we're looking at this in terms of having the A, B, and C coefficients. And notice that there's not really an A coefficient, but there is a B coefficient and also a C coefficient. So we're looking for two numbers. In BC factoring, we're looking for two numbers that add to B and multiply to C. And what two numbers add to negative 2 and multiply to positive 4? Negative 2 and negative 2. So x minus 2, x minus 2. Now the zero product rule says set each of these equal to 0. So of course, it's the same thing twice. So if x minus 2 equals 0, then x is 2. So we found the actual ordered pair that would do this. Well, at least part of it, we found the x value. Now we can just plug in to find the corresponding y value. Well, if y is 6x minus 12, then that's 6 times 2 minus 12, 12 minus 12, and that's 0. Now, a lot of people looking at this video might be wondering, well, why didn't we just put this into Desmos? Of course you can put this into Desmos, and I'm about to show you that right now. But to be ready for your SAT, you have to be ready for the easy questions and the hard questions. So you have to be able to do what I just did, even if there are some questions out there where it's not necessarily needed for you to do that method in this situation. But this is something you must be good at to be able to handle an SAT. Now let's show you the Desmos way. Now, if you went into Desmos and typed in y equals x minus 2, x plus 4, y equals 6x minus 12, you'd get the two graphs. Desmos has the advantage of being able to zoom in and out in case, for let's say, for some reason, you really needed to know exactly where these two things intersect. Desmos is pretty good at that. You can kind of just click in this area and it'll tell you where they intersect. It'll also tell you x-intercepts and things like that. Here, we just needed to know how many times they intersect. So now looking at this graph, it is actually quite ambiguous. The intersection is kind of hard to see. Maybe you could mess with the domain and range in the settings so you can really find out, is this thing overlapping twice or is it just kissing just barely once? But you know what? Coming over to Desmos kind of says maybe the algebraic method was actually better here because we know for sure that this thing hits at 2, 0, and there's one and only one answer. In any case, the answer here is C. Going to question 13, here we have two triangles. They're said to be similar to one another. They're right triangles, and there's some trigonometry involved. So first, let's talk about similar shapes. Similar shapes have the same shape as each other, which means they have the same angles. Their sides are proportional, and when you draw them, you should draw them in the same order according to their naming. So let's start with that part. Let's draw two right triangles. We're being told that G and K are the right angles. But now the names of them are FGH and JKL. So if we're using the same order, just imagine an order going like this, FGH and JKL. So we're drawing them in that order. And of course, the order doesn't matter too much other than to say that they have to match each other. Even though here they go out of their way to tell you which ones correspond, but we should kind of know that already. Now we're hearing that the sine of angle F is 308 over 317. So we can make sense of that by using SOHCAHTOA. That acronym there tells you that the sine is the opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. So we're talking about the sine of F. So that means we're standing at F. That's where we put our theta symbol. First thing you do is go right across from there and call that the opposite. The hypotenuse of a right triangle never changes, and the one left over, that's the adjacent. Now, right here, SOH, if sine is opposite over hypotenuse, and here we're told that that's 308 over 317, then the opposite can have the 308, and the hypotenuse can have the 317. Now, the idea of similar shapes is that they have the same angles as one another. So if we're being told about the sine of F, then that's the same as the sine of J, because these two angles, by definition, are the same as one another. So if a question is asking about the sine of J, well, they may as well be asking about the sine of F, and we can use the sine of F. What is the sine of F? Well, it's 308 over 317. We knew that already. So that's a nice and easy answer here. 308 over 317, which is answer choice B. Now let's go over to question 14. Here, we're getting an exponential equation format. And we should know that for the exponential equation, the A is the starting amount, the B is the way it changes, and the X is the number of times that happens. And these two variations of the exponential equation occur a lot on the digital SAT. If instead of having X in the exponent, you see X over 3, it means that our change is going to happen every 3 whatevers. In this example, every 3 years or every 3 minutes, or just every 3 times X changes by 1. On the other hand, here, if you had 3X, that would be saying that our change is happening 3 times every whatever. So, in other words, if X actually moved by 1/3, that would trigger this to happen once. But if it actually happened, if X were a 1 here, that would trigger the exponent to happen 3 times. So if you think of this as years, you'd have a starting number, it would change by a certain amount, and it would happen 3 times every 1 year. So if you're talking about making money, that one would make a lot of money. This one here would make much less money. You'd have to wait 3 years to make your profit. So coming here, we know that this is the starting amount. This is the way it changes. And this fits the format of every 410 whatevers. Now, what is the whatever here? Here, we're seeing that T is the number of minutes. So every 410 minutes. Now to answer their question. How much time in minutes does it take for the bacteria to double? Well, it's doubling every 410 minutes. So the answer here is 410. Join today to take your SAT prep to the next level. Members get access to over 1,000 solution videos answering the questions in College Board's question bank, and concept-based practice questions with videos to solidify your SAT skills. Thanks for watching. Grateful. Now going to question 15. Here, we're being asked for 4j plus 9 to be by itself. Now, we tend to refer to that as corralling. Instead of looking for one variable, we're looking for kind of like one group to be there by itself. Well, to get that out of the denominator, the easy thing to do is to multiply both sides by exactly that, by 4j plus 9. It'll cancel out on the right-hand side, leaving us with k. And on the left-hand side, it'll give us the 4j plus 9 times p. Now, we're not distributing the p into the 4j plus 9 because that's the thing we want. We want that 4j plus 9 all by itself. So what's happening right now to 4j plus 9? It's being multiplied by p. So let's do the opposite and divide it by p. This will cancel here, and now we know that 4j plus 9 is equal to k over p, which is answer choice A. Now going over to question 16, here we're getting the information about line P. We're being told this is a line, but we should know that anyway, because when x and y are to the first power, you have a line. Then we're being given the information that line R is perpendicular to that. So let's make sense of this. First of all, what do we know about line P? Well, to make more sense of it, you should solve for y. This gives you the slope-intercept formula where you can see the slope and the y-intercept. So for us, that means we need to take away 8x from both sides first. So we have 4y plus 8x is 6. If we take away 8x, what it does is it gives us the 4y by itself so that we can divide by 4 and get y after that. Now, instead of writing 6 minus 8x, I'm going to write negative 8x plus 6 because we're thinking about getting mx plus b. And here we have the 4y. Now, just divide by 4. Now look, we're not dividing the whole thing on the right by 4. We're dividing the two pieces independently because we don't want y equals mx plus b all over some number. We want each individual piece. So right now we'll have y equals negative 2x plus 3 over 2. And we've moved this into the slope-intercept formula where we can see that that's the slope and that is the y-intercept. So right now, our slope, this is the slope for line P, it's negative 2 or negative 2 over 1 because any number is itself over 1. Now, getting into perpendicular slopes are negative reciprocals of one another. If one of them's a over b, the other one's negative b over a. So we can take that negative 2 over 1, and to get the slope of line R, that would be positive 1 over 2. Because we're multiplying a negative by negative 1, that's actually going to make it positive again. And so that is our answer here. Now going to question 17. Here, we're being asked about a circle, an arc on that circle, and the corresponding angle that goes along with that arc. So let's do a little review of this topic. For central and inscribed angles, a central angle, obviously, is one that has its vertex at the center of the circle, and the measure of that angle has a 1-to-1 ratio with the inscribed arc. So if we had this 30-degree arc right here, we'd have a 30-degree angle. For inscribed angles, we have a 1-to-2 ratio with the inscribed arc. So an inscribed angle goes all the way across the circle, and if we have a 30-degree arc right here, we'll have a 15-degree angle. So here in this question, we're being asked about a central angle. So let's imagine we have this circle here. Point O is the center of the circle. And RS is an arc on the circle with a measure of 100. So this arc right here occupies 100 degrees of the circle. Now the whole way around the circle is 360 degrees. So to say 100 degrees kind of tells us what fraction of the circle we're dealing with. But what is the measure of angle ROS? That's our 1-to-1 ratio that we talked about a second ago. So if this is a 100-degree arc, then this is a 100-degree angle. And so our answer here is 100. Now going to question number 18. This is a question on types of x-intercepts. But first, let's talk for a moment about the difference between an x-intercept and a factor, or how they relate to one another. And here's an example we call the quadratic sequence. Let's just say you had this function and you had to find the x-intercepts. To find the x-intercept, y is 0. So you set it equal to 0. That's your permission to factor. And the two numbers that add to -2 and multiply to -35 are -7 and 5. Then you use the zero product rule where you set each piece independently equal to 0. And when you solve them both, you get your two x-intercepts. They're also called roots, solutions, and zeros. But for our purposes right now, let's talk about them as x-intercepts. So if you have a factor of x minus 7, that corresponds to an x-intercept of x equals +7. A factor of x plus 5, that corresponds to an x-intercept of x equals -5. So coming back to this question, if we have an x-intercept of x equals -5, that corresponds to a factor of x plus 5. Here in red, we have an x-intercept of x equals 4. So the factor would be the opposite, x minus 4. And last but not least, right here in the middle, that's an x-intercept of x equals 0. So then we would have x minus 0, or just x. So we've already talked about how this relates to the quadratic sequence. Now, let's talk about the different types of x-intercepts you can have. If a function is just kind of moving around, doing its thing, and when it crosses the x-axis, it crosses the street, that would be, most likely, a factor to the first power, what we might refer to as a single root. If, on the other hand, our function is just going around doing its thing, and when it hits the x-axis, it bounces off like a wall, that's what we would refer to as a double root, something to the second power. So it's good to know the difference between a single root that crosses and a double root that bounces off. So now we can look and see which of these are crossing and which are bouncing off. This one is crossing, so that's going to be to the first power. And this one is crossing, that can be to the first power. But this one is bouncing off. The x plus 5 factor, which came from the x-intercept of x equals -5, that one has to be to the second power. So we're looking for x plus 5, x minus 4, and x, with the x plus 5 being to the second power. And so we have the x plus 5 to the second power right here, x minus 4 to the first power, x to the first power. And so we know that this has to be answer choice B. It's the only one that fits what we said. Now let's go to question 19. Here we have a statement, and we're trying to figure out if it's exponential or linear. In a sense, it looks exponential because exponential equations tend to have percentages on them. But when we go to write this out, something different happens. And let's start. So f of x is the same as y. That equals 201% of, let's talk about that in a second, but some percent of x. Now, what is 201% in decimal form? Well, for people who are struggling with that, let's take our time with that. Let's say you had 56%. In decimal form, that would be 0.56. And the reason is because you take the decimal and move it 2 spaces left. So that's 0.56 there. So then if we have 201% and we do the same thing, take the decimal, move it 2 spaces left, you get 2.01. And so that's the number that goes right here. So even though this thing looked like an exponential equation in the beginning, it now looks kind of like a linear because it's more in a format of y equals mx plus b. And so the b would be the invisible number 0 there. So that's a linear equation if we ever saw one. And so that's either this answer or this answer. And it's increasing because a line with a positive slope would be increasing. And so it's an increasing linear equation, and that's answer choice D. Now let's go to question 20. This is a question that has too many ways that you can do it. One way is to say, okay, well, if g of x is what you get when you plug in x plus 5 for f of x, then g of x would look like this. 4x plus 5 squared plus 64 x plus 5 plus 262. Then we'd have a little legwork to clean this up. So x plus 5 all squared, that's x plus 5 times x plus 5. And if we're foiling that out, x times x is x squared, and x times 5 is 5x right there. Inner times inner, 5 times x again, that's 5x again. And last times last, that's 5 times 5, and that's 25. Combining like terms there, we'd get x squared plus 10x plus 25. And that's just replacing this part right here. So we still have to distribute a 4 and also distribute the 64. So 4x squared plus 40x plus 25 plus 64x plus 64 times 5, which is 320, plus 262. And now we have a lot of like terms. So 4x squared, there's nothing that really goes with that, so we'll bring that down. 4x squared. Then we have 40x and 64x. Well, that's 104x. Last but not least, we have 25 plus 320 plus 262. And those add to 607. So this is g of x, and we're being asked for the minimum value. For what value of x that would create the minimum value here. And that's all code for the idea of the vertex. Now, the vertex of a parabola, that's the minimum or maximum value of the parabola. So if you have an xy axis, the vertex is this point in a parabola. Now, the formula for it is negative b over 2a, but that's the x value. That's where you can find the min or the max. The y value is what the min or the max value is. And that would be what you'd get if you were to plug in that x value that you get when you use the formula. So where would this reach a minimum? Let's do x is negative b over 2a. So that's negative 104 over 2 times 4. So that's negative 104 over 8. And if we divide that on a calculator, we get negative 13. So we know the answer is negative 13 here, but there are so many ways to do this question. Another way is to look at translations. To explain that, let's imagine we have a parabola at y equals x squared, just a regular parabola. If we add to the outside, that's a vertical shift, and those are normal. So plus 5 on the outside, that would be taking our parabola up 5. But if you add to the inside, that's a horizontal shift. And those are not normal, they're backwards. So normally positives to the right and negatives to the left. But here, positive would be to the left. So this parabola would be moved left 5. In f of x notation, this one is just our regular f of x. This would be f of x plus 5. And this would be f of x plus 5. So in our question, we were seeing that g of x is f of x plus 5. So in other words, to get g of x, you take f of x and you move it left 5. So if we take the vertex of f of x, the x value of the vertex is negative b over 2a, which would be negative 64 over 2 times 4, because this is our a, b, and c. So negative b over 2a is negative 64 over 2 times 4. In other words, negative 64 over 8, and that's negative 8. So just imagine you have an xy axis. We don't know how tall this thing is, but we know the vertex is at x equals negative 8. Now, if we move it left 5, the vertex will now be at negative 13. So g of x would be somewhere here. If f of x is the blue one, then g of x is the red one, and it has its minimum at x equals negative 13. Now we have one last way we can do this, which is through Desmos. If we know that to get g of x, you're plugging in x plus 5 to f of x, well, that would basically be like having our f of x function, and everywhere where we see an x, we're going to replace that with x plus 5. So let's just write out what that would look like real quick. G of x is f of x with x plus 5 replaced into it. So 4x plus 5 plus, and that's squared, plus 64 x plus 5 plus 262. And what does that look like on Desmos? So what you're looking at here is that we went over to Desmos and we plugged in exactly what we had. 4x plus 5 squared plus 64 x plus 5 plus 262. And what you're seeing is a parabola in this space. Desmos is great for zooming in and out. When you take an SAT, you should have access to Desmos and also bring in your graphing calculator. You need both. But where is the minimum here? Desmos is really good at telling you where the minimum or maximum would be. And you can see it's at x equals negative 13. We don't care about the 6 because we're only being asked about the x value. So that's negative 13. And so that's the answer of negative 13 yet again. So on question 20, we showed you 3 different ways to get the same answer. Now going over to question 21, here we have a sample that was taken out of a population where they were asking people who they would vote for, and then we're being asked to scale that out into the bigger population. So let's just rewrite the chart down here. For Cruz, 483, and for Smith, 320. The total is 803. Now, from the whole population, the total there is 6,424. And we can call Cruz's amount of the vote X and Smith's, we can call that Y. But when you have a proportion chart like this, wherever you see a rectangle, you can create a proportion. So we can say 483 over 803 equals X over 6424. Similarly, we can say 320 over 803 equals Y over 6424. So let's write that. 320 over 803 equals Y over 6424. Now we can just cross multiply both of these and solve. So for the first one, we can say 483 times 6424 equals 803 times X. And for the second, we can say 320 times 6424 equals 803 times Y. So let's throw those two into the calculator for the pink one. 483 times 6424 is a really big number. Divided by 803, that gives you 3,864. And that's going to go right here on our chart. And for the purple one, 320 times 6,424, and then divide that by 803. And that's 2,560. Now, for people who didn't understand why we did it that way, we basically said that we were multiplying 483 times 6,424 equals 803 times X. And after you multiply out, you divide by 803. Similarly here, we were saying 320 times 6,424 equals 803 times Y. And after you multiply there, you divide by 803 as well. So here we have 2,560. And the question is asking us, by how many votes would Cruz win? Well, in the greater population, Cruz would get this number of votes and Smith would get this number. So by how many more would this guy win? That's a question of subtracting the two numbers, 3,864 minus 2,560. Subtracting those on the calculator, and you'll get B, 1,304. Now let's go to question 22. This one is asking us for an intersection. And even if it didn't specifically say intersection, we know we have two functions and we have a discussion of the answers. So that's an intersection. And for intersections, you want to get both of your equations in the y equals format and set them equal. So let's start by doing that. 2x squared minus 21x plus 64 equals 3x plus a. Now here we have a quadratic situation, and the instinct needs to be to get everything on one side equal to 0, preferably with the x squared term being positive. So for us, that means taking away 3x and taking away a from both sides. So 2x squared minus 24x plus 64 minus a equals 0. So right now, if a quadratic is in the format of ax squared plus bx plus c as more of like a standard equation, then for us, our a equals 2, our b is negative 24, and our c is surprisingly 64 minus a. C is everything that doesn't have an x attached to it. Now, the reason we're organizing this so well is because this is a classic situation for us to use the discriminant. Now, if you don't have the quadratic formula already memorized, you definitely must. But this is the application of that talks about how the number under the radical determines how many answers you'll have. If you have a positive under the radical, you'll have 2 solutions because you'd be adding and subtracting. A 0 under the radical, you'd have 1 solution because you wouldn't be adding or subtracting. Here, the answer would just be 2/3 in this sample. And if you had a negative under the radical, you'd have no solutions because you're not allowed to have a negative under a radical. So coming over here, we need to go ahead and set the discriminant equal to 0 because we're being told that there's 1 solution. So b squared minus 4ac has to equal 0. And we already know what our a, b, and c are. So let's go ahead and start using that. So b squared, negative 24 squared, minus 4 times 2 times 64 minus a equals 0. Now, once again, we're setting it equal to 0 because in this situation right here, if the discriminant were 0, that would result in 1 solution. So when they tell us in this question that there is 1 solution, this happens at 1 point, that's our hint that this whole thing, b squared minus 4ac, the part under the radical, should equal 0. So now 24 squared is 576 minus 8, 64 minus a equals 0. 576 minus 512 plus 8a, so we're distributing here, equals 0. 64 plus 8a equals 0. Take away 64 from both sides. 8a is negative 64 and divide by 8, and you'd get negative 8. But be careful not to pick this answer right now, because that'll happen a lot on the SAT where you feel like you just got an answer, but it's actually not what they were asking us for. The question was asking us for the value of x. So that means that we can maybe go into here and say, well, if a is negative 8, then this was y equals 3x minus 8. And now we'll actually find the intersection now that we have an answer for a. So once again, for intersections, you set them equal. So let's go ahead and write it down here actually. 2x squared minus 21x plus 64 equals 3x minus 8. Get everything on one side equal to 0 because that's what you do for quadratics. Take away 3x, add 8. You have 2x squared minus 24x plus 72 equals 0. And there's a little trick here. Here we have a GCF, and it makes everything a ton easier to realize that you can divide both sides by 2. X squared minus 12x plus 36 equals 0. Now we're in a BC factoring situation. We have a BC quadratic. There's no number in the A spot of the quadratic. So it's BC factoring, which means we need 2 numbers that add to negative 12 and multiply to 36. What 2 numbers do that? X minus 6 and x minus 6. So we can write that as x minus 6 squared equals 0. Take the square root of both sides, And we'll get x minus 6 is 0. Add 6 to both sides, and you get x equals 6, which is answer choice C for this incredibly long question. Join today to take your SAT prep to the next level. Members get access to over 1,000 solution videos answering the questions in College Board's question bank, and concept-based practice questions with videos to solidify your SAT skills. Thanks for watching. Grateful.